Hello, welcome back. So now we are into our fifth video for chapter 16. And in this video, we're going to talk some more about conjugate acid-base pairs. Now, we use these language of conjugate acid-base pairs. I believe that was in video 1, maybe video 2 of this chapter. And so if you haven't watched those or if you don't remember those, I'd recommend going back and taking a look. Okay, so some vocabulary review. We have the reaction of how a weak acid disassociates in water and the Ka that corresponds with that weak acid. We also have the relationship of how a weak base reacts with water and the equilibrium expression that corresponds to that one. And then this is how water, and remember that water is a liquid and it's disassociating into aqueous species, and water forms an equilibrium reaction that is defined by Kw. We are going to use these three relationships to understand conjugate acid and base pairs. So, if we have a weak acid, Ha, reacting with water to form the hydronium ion and A-, it is described by this Ka. Now, remember that this A- is what is called the conjugate base. It is the base that results from the acid reacting with water. And so what we can do is we can also look at how this conjugate base, this A- reacts with water. And when A- is dissolved in water, it forms Ha and OH-. And so we call Ha and A- conjugate pairs. So something that we can do is if we take the Ka, this relates to Ha, and we multiply it by the Kb, relating A-, the reaction of A-, we get this expression here. And so all I've done is I've taken the Ka and I've plugged it in this spot, and I've taken the Kb and I've plugged it in here. And notice how I have an A- on the bottom and an A- on the bottom. I have an Ha on the bottom and an Ha on the top. I'm sorry, I should have said that I have an A- on the bottom and an A- on the top. And so they cancel. And that leaves us with H3O plus times OH-, which is Kw. So we can summarize this relationship that Ka times Kb is equal to Kw. And so this is just repeating this relationship. Now, this relationship is only true for the Ka and the Kb of species who are conjugates of one another. And so this is true if we want to look at acetic acid and the acetate ion. These are conjugate pairs. So the Ka for the acetic acid and the Kb for the acetate are related via this relationship. Okay, so let's do an example. The Ka of acetic acid is 1.8 times 10 to the minus 5. What is the Kb of the acetate ion? So we talked about how acetic acid is the acid. So when we put it in water, it forms an equilibrium with the acetate ion plus H3O plus, and so it is described by a Ka that has the expression CH3COO minus times the hydronium concentration divided by the concentration of the acetic acid. And then the acetate in water acts as a base, so it is in equilibrium with the acetic acid plus the OH minus and has a Kb of acetic acid times hydroxide divided by acetate. So since the acetic acid and the acetate are conjugate acid-base pairs of each other, we can use the Ka of the acetic acid to find the Kb of the acetate ion. And so we know that Ka times Kb equals Kw, and Ka is 1.8 times 10 to the minus 5. So I have 1.8 times 10 to the minus 5 times Kb is equal to 1 times 10 to the minus 14. And Kb is going to be equal to if I divide this out, I get 5.6 times 10 to the minus 10. And this is the value of the Kb that corresponds to the reaction of the acetate ion with water. So this is just the exact example written out in more typed up, neater handwriting. And so you see how I plugged things in and I divided out and I got the same answer that I showed you earlier. Okay, so this is going to come really helpful in a couple of videos whenever we start trying to figure out if salts that we dissolve in water behave as acids, bases, or neutrals. I guess I should re-say that. We will be trying to predict the pH of a solution when a salt is dissolved in water. And we want to know if the pH of that solution overall is acidic, basic, or neutral. And so to figure that out, we are going to need to use these Ka, Kb values. And many times we're going to have to manipulate what we see in the table to be able to match the reaction that we need. So I hope this makes sense. Remember, I have lots of office hours, and there's a discussion board on D2L, and I'm happy to answer questions via email, chat, whatever you need. Thank you.